Hello, and welcome to my video on deriving the formula for the length of a curve. This is a Calculus BC topic, and it's in Chapter 7 of the Kennedy book that we use at San Ynez High School. So the way this starts off is we do a slope triangle, and that slope triangle would have delta x here and delta y here. Okay, and notice if we were to zoom in on this, and of course this would be, I'm going to call it delta L for arc length. I believe the book uses an S. Either way, it doesn't matter, it's just a variable name. So if we zoom in on that, and you'll see what I mean, we'll zoom in here, and we're zoomed in on that little section, so that's the slope triangle. So this is our delta x, and since we've zoomed in so far, let's call this a dx, and this a dy. And then this will be dl for the little tiny change in arc length. And notice these are differentials. So we can write the relationship between dx, dy, and dl with the slope triangle by writing the dl would be equal to the square root of dy squared plus dx squared. It's just the Pythagorean theorem. Okay, and what we're going to want to do is solve for dl, and then we'll be able to take we have too many variables here for one thing. So what we could do is we could change this to either a dy dx or a dx dy by multiplying by multiplying by 1, of course. We're going to multiply by dx squared over dx squared inside the square root. What that lets us do is it lets us distribute this one, the denominator, into these, and then we'll cancel out that dx squared, making a 1, and the dy squared will become dy dx squared. We'll see what I mean here in a moment. So dl equals square root of, that's a big square root now, and that would be dy over dx. No, they're both squared, so I can write that as the quotient squared, plus, and then dx squared over dx squared is just 1. And then square root of dx squared is just dx. I know technically that would be the absolute value of dx, but we're assuming we're moving along the curve from left to right, so that would be a positive dx value. All right, so now you can see we have this in terms, dl in terms of dy dx, which is just f primed, and we just have to take an integral. Let's go ahead and change colors here. So we'll take an integral of this for both sides. So integral there, integral there. Of course, the integral of dl is going to be L, the arc length, and this side will be the integral. And we have to, from where we start to where we end, we're going to have to accumulate all those little values. Square root of, and that's dy dx squared plus 1 with respect to x. Okay, there's an alternate version. If instead of multiplying by dx squared over dx squared, we multiplied by dy squared over dy squared, we would get it in terms of dy. So L would be equal to the integral from a to b of square root of dx over dy, the quantity squared, plus 1 dy. And we could use either one of those versions depending on whether the function is written if it's written as a function of x, in terms of y, or y in terms of x. All right, so here's our two formulas. Pretty easy derivation, really. And the reason I like to show this is I think it helps you remember the formula. Next, I'll be doing an example or two of using these formulas. Thanks for listening. I hope this is helpful to you.